I'm Patrick Löwenstein and I'm working as an Android developer at Tailored Apps. It's a mobile app agency based in Vienna. So today I'm going to talk about Model-View-ViewModel architecture with the data binding library. So what I want to show you with this talk is that by using data binding, you need to write less code. And by having the separation of the business logic and presentation logic layers with the Model-View-ViewModel library, you write cleaner code. So first I'll talk about data binding a bit and give you an introduction of how to use it. And then we'll talk about how we can set up the whole MVVM architecture. Also, there's an article on my blog, so you can read about everything that I'll tell you later on the blog if you just need to check something again. And there's also some code on GitHub. The links will be there at the slides at the end. So let's start. So actually, what is data binding? Data binding means that data from a data source is bound to a data consumer. So usually this means data from local storage or network is bound to layouts. Another important feature of data binding is that data changes are synchronized automatically between data sources and the data consumer. So what are the benefits? So what do you get from that? We've all been writing this kind of code. Lots of find view by ID calls, then all those setters and listeners. Even with tools like Butterknife, this does not really get better. With the data binding library, this is a thing of the past. A binding class is provided on compile time for you, which provides all the views with an ID in the layout as fields. Also, all those setters that you would have to call here are actually called in the binding class with their binding logic, so you don't need to call this. All in all, this means far less code in your activities and fragments. Ideally, you should just have to have some small code to set up the whole thing and then you're done. So now let's look how we can set this up in your app. First, go to your app's build.gradle file and add data binding enable true in the Android section. This tells the build system that it needs to start processing the layout files and create the binding classes for it. Next, go to the layout file where you want to use data binding and wrap the topmost element in a layout tag. Again, this creates a binding class for this layout. The name of the binding class is the same as the name of the XML layout file. So if your XML layout file is called like activity_main.xml, the binding class will be called activity main binding. Also note that the namespace declarations now move into the top tag in the layout tag. Next thing to do, inside the layout, declare the data that you want to bind in this layout. You can declare multiple variables here, each one with a name and a type. Usually with MVVM architecture you only have one variable, your view model, but we will see this later. You can also import classes here so you can use its constants and static methods if you like to. So finally, let's look at how we can actually bind data now. Data binding expressions start with an @ sign and are enclosed by brackets. You can use all the variables and imports you declared in the data section. So in the expression itself, you could do nearly everything you can do in code, for example, arithmetic operations and string concatenation. So with the visibility attribute, you also see that there's a ternary if-then-else operator. And with the text attribute, you see there is a null coalescing operator. This means you can provide a default value if the value you actually want to bind is null. So what happens here with the text attribute, if vm.text is null, it automatically provides the value on the right of the null coalescing operator. Resource success happens like with normal layouts. You can see this here with the padding attribute, where we choose a different dimension based on a Boolean value of our view model. So how do we actually access the properties of our variables? As you can see, we just access it via the field access syntax, even though you maybe implemented it as getters and setters in the code. So For example, if you have a getText method in your view model, you can just write vm.text and it works. So maybe some of you have been using Kotlin already, so you know how this works already. Finally, some very small restrictions apply. For example, you cannot create any new objects here, but I don't know how, you don't really need to, so yeah. All in all, the data binding library is really powerful. Now that we know how binding works, we need to know which attributes we actually can bind to. So most properties of the standard views are already supported. What happens here internally in the data binding library is that the library looks for a setter with the name of the attribute which you want to bind to and the corresponding parameter type. So for example, if you want to bind a string value to the Android text attribute, it internally looks for a setText method on the view class with a string parameter. So this makes it really easy to make it work with all different kinds of attributes because it does not need to have a separate binding adapter for it. We will see this later. Also, quite a cool thing about this is that you can also bind things which do not have a setter, which do not have a corresponding attribute in the layout. For example, at the bottom you see we bind a recycler-view adapter directly in the layout. This works because if you bind to the app adapter attribute, the data binding library just looks if there is a set adapter method in the view, and the recycler view of course has a set adapter method. So not every standard attribute is supported in the views. So with padding left, for example, there is no set padding left method in the view class. In this case, the data binding library already provides a custom setter, so this works out of the box. But what, for example, with layout margin bottom? This does not work out of the box. What can we do about it? We can just write our custom setters. Those are called binding adapters. So create a method and annotate it with binding adapter. Then provide the name of the attribute you want the binding adapter to be called for inside the parameter of binding adapter. Next thing, the method has to be public static void. The first parameter is the view type for which you want the binding adapter to be called. Actually, subtypes are also supported. The second parameter is the type of the data you want to bind. So if we look at the slides, this is an example binding adapter for the layout margin bottom attribute, which works for views and subclasses and binds an integer value. So it's pretty easy. Now, all that's left for you to do is implement it. In this case, it's pretty simple. Just get the layout parameters and set the bottom margin. You can also supply multiple attributes to the binding adapter annotation. So, for example, you can use this to have an image loading binding adapter where you provide with one attribute the image URL and with the second attribute the drawable resource ID. So this can be pretty handy. As you can see, if you have multiple attributes, each attribute has a corresponding parameter. So in the order of the how you provide the attributes, you have parameters in the method then. So what you have to keep in mind, if you use binding adapters with multiple attributes, those will only get called if all of those attributes are really bound on the view. So for example, if you have this binding adapter and you only bind to the image URL attribute, this binding adapter will not be called. But you can just have a separate binding adapter which just uses the image URL. So this is pretty flexible. As you can see, I just used then Picasso to load the image, so image loading gets pretty easy with this. Now that we know how to do binding in XML and how to create custom setters, we need to look at how to apply the binding in code. So the first thing you need to do is get an instance of the binding class for your specific layout. The data binding library again does all the hard work for you, and creates the class itself, the binding class. So how to get it? Just use the helper methods in data binding util. For activities you would use setContentView, for fragments you would use inflate, and for view holders you would use bind. So as I told you before, you can access all the views with an ID in the layout as fields on the binding. You can see this here at the bottom. If you define an ID text_view in the layout, you can just access it via binding.textView here. And now on to the most important thing for Model-View-ViewModel architecture. On the binding, you also set the variables you declared in the layout. So that's actually the place where you connect the two, where you connect the view model and the binding. So we had a variable called VM in our layout. So what we can do here is now binding.set VM and provide in the view model. Now both are connected. So as I told you, one of the benefits of the data binding library is that data auto updates when something the layout auto updates when something changes in your variables. So however, there still needs to be a mechanism to notify the data binding library of updates. For this, an observable class is defined in the data binding library. It's just an interface basically. And if any of you is using RxJava, it's not the same observable, so it's a different type. So for simple data types like integers or booleans, the data binding library also already provides observable types. For example, observable int or observable boolean. In more complex situations, like with our view model, there is a base observable class, as you can see over here. You can just extend this class, and then there are some methods provided, which we will see later, to notify the data binding library of changes. So here we have a very basic view model on the slides, just with one model object and two properties at the bottom, getText and getAmount. So let's look at the setter methods now. When we use setModel, we exchange the whole data that is bound. So everything gets changed basically. What we want to do now is we want to have the data binding library update all the bound properties. So this is pretty easy now with base observable. We just call notify change and the data binding library rebinds the whole layout. If you look at setAmount, only one property is changed. So what we do not want here is that the whole layout is rebound, because there will be lots of unnecessary stuff that is updated even if the data did not change. We only want to update those bindings that use this exact property. So what we do now, we add an add bindable annotation to the getter of the property, in our case to getAmount. This then creates a field in the BR class, which is named like the getter or like the property. So in this case it's br.amount. You can then pass this in to notify property changed, and you're done. The data binding library then recognizes this and only updates those part of the layout which use this exact property. So this is actually pretty awesome, because you can control with this single method what is updated, but you don't have to write the logic for it. So this was the introduction to data binding. A short summary. Declare the variables in your layouts and use them to bind to the attributes of your views. Then create the binding in code and set the variables on the binding. Finally, make sure that all your variables implement the observable interface, so data changes are automatically synchronized. So now let's talk about Model-View-ViewModel architecture. First, we'll take a look at those three components. So first, the view. The view is basically our user interface, our layout. In Android, this usually means an activity, fragment, or view holder with a corresponding inflated XML layout. The model is our business logic layer. it provides methods for data interaction. The view model then acts as the middleman between the view and model. It exposes data from the model via properties and also provides commands for view events like clicks. Also, it contains your UI state and most importantly all your presentation logic. So the view and the view model mainly interact through the data binding library. Ideally, view and view model should not even know about each other. However, in Android that's a different kind of situation. So first you have to save and restore state, but the state is now in the view model. Second, we have some lifecycle events and callbacks. And since everything is now done in the view model, you somehow need to forward this to the view model. And third, you might encounter other situations where you need to call view methods directly. So what do? We have interfaces for both the view and the view model and use those interfaces for communication between the two. So now on to how view model and model interact. Basically, the view model uses the model layer for data access. For example, it can fetch some data or update some data in the database or change something. Ideally, the model layer should also notify the view model of any data changes, but this can depend on your concrete implementation. So basically, the separation of the presentation logic and the business logic layer means your presentation logic is easily testable. And together with data binding, this means you have to write less code, as we have seen, and you produce cleaner code. And it's even great for maintenance and testability, as we will see later. So now let's look at an example. On the left side, we have a very basic view model, and on the right side, we have the corresponding layout file. In the layout, note that we only have one variable. It's our view model, named VM with our type, in this case my view model. So the view model provides all the properties you need to bind. This can be as easy as just returning a string or more complex, depending on your use case. So here we have just one text property and a Boolean property. Our layer shows an edit text and we want to bind the text to the view model. Also, we have the Boolean value which declares whether the edit text field should be shown. And lastly, we have a button for which we need to define the command so that we can do something when the button is clicked. So first let's look at how to connect those two for the text editing thing. With an edit text, we usually also want to have the user input saved. But until now, we only ever bound things from the view model to the layout, but not the other way around. With edit text, we also want to have data set back on our view model. So actually, this is pretty easy with data binding. You can see we have the getText method already. Now we also add a setText method in the view model. Then in the layout, with the edit text on the text attribute, we can just enable two-way data binding. You can enable two-way data binding by providing an equal sign between the at and the brackets, as you can see here. What this does now is it just calls the setter on your view model for this specific property that you bound, and you're good to go. Now every time something is changed or input in your edit text, the setter in your view model is called. Traditionally, you would have to deal with a text watcher and so on. So this is actually pretty awesome. Again, the data binding library does all the hard work for you. So now let's look at the should show text boolean. We can just bind this boolean property to the visibility attribute. However, we still need to write a custom binding adapter for this to work. But this is pretty easy. We just have a boolean property and we set the visibility to gone or visible. If we have time left, there will be some live coding at the end, but I don't know where I would show this to you. So on to the button press. You see we have already a command in the view model. It's called onButtonClick. this command then just saves the data and does anything it needs to do, but it's not relevant to us now. So how do we actually connect this with the button onClick event? We just have an app onClick attribute and just bind the method reference of the command. So what we say here is, in the onClick event, call this method. That's why we use a method reference here. So now you're good to go. It just then calls onButtonClick every time the onClick is called. Again, for this to work, you need a custom binding adapter. I hope we can go to this later in the live coding. I think we have some time. Also, I would encourage you to just write custom binding adapters if you find the need to it. It's pretty awesome because you can do many things directly in the layout, as I told you already with image loading. Then you can just bind the image URL in the layout and you're done. So you have one place in the code, your binding adapter, where you code this, and it works everywhere. So this is pretty awesome. So with MVVM, we still have to handle lifecycle and state, as I already told you. So the first thing I suggest is making a base class for each view model. Then you can handle all those stuff here. So, sorry. So you know, in Android, all those lifecycle events are called in your activities, fragments, and so on. So we need some methods we can forward this to in the view model. I suggest you only create two callbacks here. Attach view when the view is created, and detach view when the view is destroyed. So in attach view, you can also pass in the view interface. We talked about this earlier. We have an interface for the view and an interface for the view model. So you can pass in the view interface here, so the view model can call view methods, view commands, if ever needed. So attach view is then called in an activity onCreate or in a fragment onCreate view. And detach view would then be called in onDestroy or onDestroy view. So this is actually pretty easy. So for state saving and restoring, you know, in Android the system can kill your components at any time because memory is low, or I don't know, because of configuration changes and so on. So you somehow need to have a mechanism for saving and restoring state. So for restoring state, I suggest directly passing in the saved instance state bundle into the attach view method, so you can handle the restoring there. For saving the instance state, we can create a separate callback, which is then called in the activity onSave instance state. So again, this is not that much of a problem, and it's pretty short, the whole base class. But it handles everything for you then, and you have a base for all your view models. So some of you might have noticed that this brings some of the Android specifics into your view model. Some people argue that it's bad for testing and so on to have Android specific classes in the view model. But in my opinion, this does not really hurt testability. You can mock this stuff and just test. It's no problem. We will see an example of testing later. So now let's talk about your views, the activities and fragments and so on. Here I too recommend you to create base classes. We see a base class here for activity. Just a note, you can just look at the article at the end or on GitHub if you want to take a look at this, so you don't have to remember this now, everything, the whole code thing. So the first thing I want to note is that we have to somehow inject the view model before we use the other components. So I suggest you use a dependency injection framework for this, so that the view model is already available before we call those other methods. What we then can do is have just one method, in our case set and bind content view, that sets the whole architecture thing we just created with the view model up. So what does this method do? The first thing it does is it sets the content view and gets the binding class instance for us. This is the first line in set and bind content view. Next thing it does, it sets the view model on the binding so that those two are connected. And the last thing it does, it attaches the view, in this case our activity, to the view model. providing this is in this case the view interface and the saved instance state. Remember, we defined this before in the base view model. So with this, you just have to set up your injection thing so that the view model is already available, and then you just have to call this single method. That's all. Usually your activities will just have like 3 lines of code, and everything else is then handled in the view model. So this is pretty awesome. As you can see, saving instance state and the detach view can also be handled here directly in the base class. So just forward the save instance state callback in the onSave instance state. So basically just forward it. In onDestroy, you can just call detach view on the view model. So now everything is handled in the base classes, or most of it actually. You still have to call setDefineContent view, and you're good to go. So actually that's all you need. With these base classes, you can start implementing Model-View-ViewModel architecture in your apps. However, there are a few things you can do to further improve your app's architecture. I will not go into too much detail here because this would be too long for this talk. First, dependency injection. We already talked about this now. So I just suggest you use dependency injection to inject other components into your view model, and for example also the view model in your activities and so on. I always recommend using Dagger 2. So who is already using Dagger 2? There's quite a few people, so it's pretty awesome. So the benefit of this is that the view model does not care where the components come from. It just uses them, so you can exchange them at any time. Of course, this is also great for maintenance. If you ever need to change an implementation, just change it and it still works because you inject the component. But of course, it's important to rely on interfaces here to achieve true exchangeability. Now a short remark about business logic. Remember, your view models should only contain presentation logic, so please don't put any business logic in there. For data access, we can just write some some repository interfaces and then implement those with the storage option of your choice. Or for networking, for example, you can just use retrofit. You see this on the right side. So what the repository does, it just provides basic methods for data interaction, like find all, update, delete, and so on. So if you just use those basic methods, you can directly inject this repository then in your view model and use this. However, in Android you often have something like validation and so on. So please don't do these things in the view model. Create a separate component, for example for validation, that uses both the repository, that acts as a middleman between the repository and the view model, so that you don't have any business logic in your view model. You should really only have the presentation logic in your view model. So yeah. Next thing, for navigation between screens in Android, you always need to have some kind of object that the view provides. For example, you need a context to start a new activity, or you need a fragment manager to replace fragments. So what we could do now is define some commands in the view interface for navigation and call those commands in the view model. However, this brings quite some more complexity into our architecture setup. So one solution would be to define a separate navigator interface that provides some common methods like finish activity, start activity, and replace fragment. Then you can just implement this interface for both activities and fragments and inject this navigator component into your view model. So what we have achieved now is that you can do all those navigation stuff directly into your, you can do this directly in the view model. So you just call navigator.startActivity here and it just works. You don't need to call any view methods anymore. So again, this brings some Android specifics in the view model, but you can just mock the navigator interface and so on. So it's not really that bad. Actually, we will be talking about testing now. So basically unit testing your view models, your presentation logic. I always prefer to use Mockito to mock all those components that the view model uses, but you can use any mock solution you want. For example, there's also PowerMock, which can do advanced things like mocking static methods if you need this. So yeah, basically these are just JUnit tests. So we have a method annotated with @before that gets called before every test case. What we do here, we initialize our mocks so that mock objects are created for all our components. Next thing, we create an instance of our view model and provide those mock interfaces in the constructor. Lastly, we attach the view, the mock view. You can see here we also mock the view interface, so we can pass this in attach view. As saved instance state, we can just pass in null, so it does not restore anything then. Now, all that's left to do is just implement your test cases. Usually this works like this. First thing you do is you define the behavior of the mock objects if you need this. So for example, we will test now the button click thing we had earlier in the view model. What the button click should do, it should save the model in the model repository. So first thing we do is we define when the create method of the model repository is called, we return a new model. That's a method that's then used in the on button click. So we just define the behavior of the mock object. Next thing, we call the method under test on our view model. So in this case, just my viewModel.onButtonClick. Now, finally, just verify whether the behavior was correct. You can just use assert methods or verify methods to do this. What we do here, we just verify whether save on our model repository was called. And then we verify whether finish activity on our navigator was called. So this is pretty easy, as you have seen. You can test your presentation logic pretty easily if you use the Model-View-ViewModel architecture and if you use separate components for your business logic. So actually this is now everything you need, and you can start implementing this. Again, you will see a link to the article I've written which also covers these topics, so if you want to review it you can just read the article. But now for a short summary. Basically the view model is the middleman between the view and the model. The view is then automatically updated with data from the view model by using data binding. Commands in your view model are called on view events like clicks. The view model can also call commands on the view if necessary. In Android, view models can also handle basic lifecycle events and state saving and restoring. Also, I suggest you use dependency injection to inject all those components you need. And finally, a really important thing again, don't put any business logic in your view models. Just put all the presentation logic in it. So yeah, if you want to see some code, there is a GitHub repository. So this contains an example app and also a template which you can use to start your own projects with the approach as outlined in this talk. There is also a Kotlin variant of both the example app and the template. So if you like to use Kotlin, you can do it. So I think we still have some time left for, it's like at 10 I think. Do you have any questions?